In our previous video, we started with an exponential function and drew a graph based on it. In this problem, instead, we'll start with a graph and figure out what the exponential function is. We must first remember that the general form of an exponential function is y equals a times b raised to the x plus c. Once again, a is your leading coefficient, b is your base, and c is your horizontal asymptote. We can begin by locating the horizontal asymptote on the graph. We can see on the left side of the graph that we have a near horizontal line. That horizontal line is at about y equals 6. Therefore, we can label that 6 as our horizontal asymptote, and I'll draw an orange line on the graph to represent that asymptote. Therefore, we can say C, our horizontal asymptote, is automatically 6, and now we know one of the three letters. Now that we have that, let's try to find the leading coefficient. To find the leading coefficient, we're going to use the y-intercept. We can see there is a green dot representing the y-intercept, and the coordinate for that is 0, 17 over 3. This means we can let x equal 0 and let y equal 17 over 3, while also letting c equal 6, since we found that in the previous step. We can place those letters into our general form. Since our general form says y equals a times b raised to the x plus c, we can check off c, which is 6, and check off x and y, which are 0 and 17 over 3, respectively. We'll plug in 17 over 3 from y, and then say a times b raised to the 0 plus 6. But anything raised to the 0 is automatically 1. Therefore, our equation becomes 17 over 3 equals a plus 6. If we subtract 6 from both sides, on the left, 17 over 3 minus 6 will give us negative 1/3. This will be our value for a, and so we can say a is 1/3. Now that we know a and c, our final task is to find b, the base of the exponential. To find the base of the exponential, we'll have to look elsewhere on the graph and pick another point, hopefully one that is easy to read. In this graph, you have a couple of decent options. I'm going to mark two of the points that are easy to read. The first green dot I marked has a coordinate of 1, 5, x value 1, y value of 5. The green dot further to the right is at an x value of 2 and a y value of 3. Either one of them would suit our purposes, but it's easier to use 0 or 1 as your x value when you're doing an exponential function. Therefore, we'll use that one. We're going to now let a equal negative 1/3, c equal 6, since we knew both of those from before, and then let our x be 1 and our y be 5. We'll write our general form again, and then we'll place the numbers that we know into this equation. Y is now 5, a is now negative 1/3, b is still unknown. We don't have our base yet. However, we do know that x is equal to 1, so we'll have b to the first power, and we'll have a c value of 6. We're going to try to solve for b, which means we'll need to get b by itself. To get b by itself, we'll subtract 6 from both sides. This will give us negative 1 on the left, and negative 1/3 times b on the right. In order to get b by itself, we'll have to multiply by the reciprocal of the number next to b. The reciprocal of negative 1/3 is negative 3 over 1. We'll multiply that on both sides. On the left, if we take negative 3 over 1 times negative 1, we'll get positive 3. On the right, when we multiply this fraction times its reciprocal, both fractions will cancel out completely and leave just b. Therefore, we now know that b is equal to 3. Therefore, now that we have all three letters, we may write our new equation. Our new equation will be y equals a, which is negative 1/3, times b, which is 3, raised to the x, plus c, which is 6. This will be our exponential function that goes with this graph. Therefore, to find an exponential function, we need the horizontal asymptote, we need the y-intercept, and we need another point on the graph. Then we can place that in the exponential function general form to solve for each of the three unknown letters. Thank you for watching. We'll see you again soon.